Hello everybody. Can you hear me? Yes. Perfect. How are you? Fine. Who has attended my TempDB talk? Oh God. So you have now very high expectations. But this time I'm only showing code that I have written. Okay, I'm jumping over the introduction. You already know me. What's the agenda for the next 90 minutes? I want to talk about very large databases, VLDBs. So we are talking a little bit how we should design a very large database in SQL Server, why the default settings of SQL Server, when we are creating a database, why those settings are not very good. And we will also talk about partitioning, how partitioning can help when we are dealing with very large databases, and how we can recover when parts of our database are dying. Who of you has a very large database? What do you mean by very large database? You already know me. Who is using TempDB? So who is using a database with 100 gigabytes? 500? 1 terabyte? 2 terabytes? 5 terabytes? 10 terabytes? Okay, so when we are talking about a few terabytes, it's already a very large database. So the largest SQL Server database that I have seen was around 50 terabytes. So that's already very large databases. Let's talk in the first step about physical database design. When we are creating a new database in SQL Server gives us a primary file group which contains one data file, and SQL Server gives us the transaction log. So for example, when we switch over to SQL Server and we create here a new database, we have just one file, one transaction log, only the primary file group. Who is using databases in that configuration? Few of you, hopefully not with very large databases, because that configuration is not really recommended. The problem that we have with that default database structure is that a SQL Server database is only online when both the primary file group and the transaction log is online. So imagine you have a database with a few hundred gigabytes, with a few terabytes, and you put everything in the primary file group. In that case, you have to recover your complete database, your complete primary file group, which contains your whole data, to bring your SQL Server database online. So for example, when our primary file group, when a file in the primary file group gets lost, maybe we have a storage error, then our whole database is offline. Normally, when we are talking about databases, you are dealing with a huge amount of historical data. So you have some operational data for the current year, 2014, and then you have for the past historical data. When you are recovering a database, it's a good idea to recover in the first step your operational data, the data for the current year 2014, to bring your database online, and afterwards you can restore all the other historical data, so data from the year 2013, 2012, 2011, 2010, and so on. So with that default structure that SQL Server creates by default, we have a very huge problem when we are working with larger databases. So the primary file group and the transaction log is the most crucial part of our SQL Server database. The primary file group contains all our system tables, and the transaction log contains all the transaction log records that we have generated through our write activity, insert, update, and delete. Means when our primary file group gets damaged, we have lost our complete database, our database is offline, and we have to restore, we have to recover our whole complete database. As I've said, SQL Server database is only online when the primary file group is online. So just by working with the primary file group isn't really a good idea. So you should create multiple file groups. A file group in a SQL Server database is just a logical container. It's just a logical concept, and within a file group, within a logical container, you can put physical files. So for example, we can say we have our primary file group, we always have the primary file group, and we are not putting any table in the primary file group. Nothing. The primary file group should just contain the system tables of SQL Server, nothing more. And then we have some other file groups. For example, we can have a secondary file group where we have our operational data for the current year, 2014. Then we have different additional file groups where we put data from other years. For example, 2013, whoops. Well, it's the first time during those 2 days that I'm not presenting on the video wall. But the nice thing is my laser pointer is working. And I can't work with it. I can't work with it. Not very good. So as you can see, we can have an additional file group, for example, for the data of 2013, 2010, maybe additional file groups for 2011 and 2010. And of course, we have our transaction log. We always need our transaction log. When we are losing our transaction log, we have lost our database. So the transaction log is also the most crucial part of our SQL Server database. This means in that scenario, our database is online when the primary file group is online and the transaction log is online. So when we have no data in the primary file group except the system tables from SQL Server, our database is online immediately, within a few seconds. We're just restoring from a backup the primary file group, and that's it. Means our database is online, and then we can restore file group by file group. Of course, we are starting with our file group where we have our operational data from 2014, because that's the most crucial data, because we need that data, because that data is needed to drive our business. And afterwards, piece by piece, we are restoring our older file groups which are containing the historical data. Okay? Makes sense? You're already looking a little bit impressed or annoyed? But you get the concept. So the advantages: we are storing no data in our primary file group, except the system tables. Some other components of SQL Server, like Service Broker, they are also storing data in the primary file group. But you can't change that. That's also sometimes a little bit bad, because when you're creating tables, when you're creating indexes, you can define in which file group you want to create them. When you're using other functionalities like Service Broker, they're just putting their internal tables in the primary file group. So also not really a good approach. Means our database is online very, very fast. Of course, database is online, but we have still no data. But of course, we can restore our operational data and then step by step our older data. Means our data is also separated. We have our operational data for the current year, we have our old historical data. So it improves our database availability. It doesn't matter when the old data from 2010 is offline for some hours. We just need that data for reporting, nothing more. The only data we care about is the current data, the operational data for our current year. But the older data doesn't really matter because we need that data only for reporting. Means, in the case of a failure, our recovery time is just shorter because we don't have to restore our complete database in one touch. We are just restoring our database piece by piece. It's a so-called piecemeal restore in SQL Server. Means SQL Server gives us here several recovery options and recovery paths, how we can bring our database in the case of a failure online. As you can see, when our database dies, for example, when a secondary file group dies, our database is still online as long as the primary and the transaction log is online. So when you're losing one other file group, it doesn't matter. Your database is still online as long as you're using Enterprise Edition. In Standard Edition, your whole database is offline. But when you're dealing with a very large database, you're hopefully not using Express Edition or Standard Edition. Okay? So that's the goal, to bring our database as fast as possible online by not putting any information in the primary file group. As I've said, when we are on the Enterprise Edition, our database is online as long as our primary file group and transaction log is online. Things are changing in the Standard Edition. In the Standard Edition, the database is only online if all file groups are online. So that's a huge difference between Enterprise and Standard Edition of SQL Server. What other benefits we have? As I've said, a file group is just a logical container, and within that file group, we can store physical files. Means we can put those files on different storage subsystems. Imagine our operational data for the current year should be accessible very, very fast. So we put the file group, the files in the file group of the current year on SSD drives because they are fast. The data from the previous year, maybe we put that data on a weight 10 array. And all the older data, we can put on a weight 5 or even weight 6. So the older the data is, the slower the storage is. Means the cheaper the storage gets. It doesn't make sense to put the whole database on a very fast SSD drive. Okay? Of course, to split up our data between multiple years, between multiple files, we need some functionalities. For that reason, SQL Server provides us partitioning. Partitioning was introduced back with SQL Server 2005. It's almost a 9-year-old technology in SQL Server. Why should we partition our tables? Mainly to work with those tables in a more easier way. Microsoft recommends partitioning tables when a table is at least 100 gigabytes large. Just think about that. One table. We are not talking about the whole database, just about one table. Who has tables with more than 100 gigabytes? Everyone who has, hopefully, a very large database. Who has partitioned those tables? Perfect. So when you're just dealing with a database of 100 gigabytes, forget about partitioning. Partitioning only makes sense when we are dealing with huge, large tables. For example, maintenance. You can rebuild your partitions individually. Starting with SQL Server 2014, you can even rebuild partitions online. Before 2014, SQL Server 2014, a rebuild on a partition level was just an offline operation. Microsoft has fixed that with SQL Server 2014. So it doesn't make sense to always rebuild all your indexes with all the historical data, because the historical data isn't changing anymore. It's just static data. You're just reading that data. So when you have no partitioning in use, you always have to rebuild the whole complete clustered index and all non-clustered indexes. So in that case, partitioning can also help you. As we will see later, partitioning also helps us with availability. So parts of our table, specific partitions can be online, other partitions are just offline, when you put them in different file groups. Even when we are talking about locking, blocking, deadlocking, can also be improved when you are working with partitioning. For example, lock escalations. By default, SQL Server escalates individual locks to a table level. When you are using partitioning, you can instruct SQL Server to escalate on a partition level. Means you're just locking a specific partition instead of the whole table. But you have to be very, very careful here, because you can introduce deadlock scenarios. That's also the reason why partitioned level lock escalations are disabled by default. So you have to analyze your workload if you can run into deadlock situations or not. And even for data archival, I have some customers, they have huge problems. They have no or almost no idea how to delete data from tables. Imagine you have very large logging auditing tables. They have so many inserts per second into those tables that they are unable to delete that data in the meantime. So the table grows larger as they are able to delete data from that table. Just think about that. Think about a website where you're moving your mouse, and every mouse move must be audited in a database table. Sounds crazy, but I know a few customers which have to do that. Okay? So their tables are just growing faster as they can delete from those tables data. So you can predict when your storage is full, and you can just expand your storage over time again and again and again. So when you're using here partitioning, you can switch out older partitions just as a metadata operation. Means SQL Server is internally just changing pointers, and you are switching out a partition into a staging table within a few milliseconds. So you are not really moving any physical data. You're just changing internally in the metadata of SQL Server pointers. Okay? So what problems we have with one single large unpartitioned table? As we have said, index creation, index rebuilds, all or nothing. So when you have 10 years of data in that table, you have to rebuild your whole clustered and non-clustered indexes. So you're just rebuilding data that hasn't changed over time anymore. Backup and restore, it's the same. Imagine when you are backing up a very large table. You are backing up static historical data over and over again, which isn't changing anymore. We've already talked about lock escalations, and what is also very, very important, you have different access pattern. In your operational data for the current year, you are inserting, you are deleting, you are changing data, so you have a write activity. But in the older historical data, you have no write activity, hopefully. You're just reading data for reporting, for business intelligence, for data warehousing purposes. Means it would be really, really interesting to index that data differently. Maybe you want to have a more aggressive indexing strategy for your historical data, because you want to read that data very, very fast, and in your operational data for your current year, you don't want to have too much indexes, because it's mainly a write workload, insert, update, and delete. And also the question, how can we delete very, very efficiently data? Who has already deleted from a table More than 5,000 rows. Everyone, come on, everyone. That's a huge problem because you have triggered a log escalation. You have locked your whole table with an exclusive log. No one else was able in the meantime to read and write from that table. Just think about that. Deleting data from a huge table in SQL Server is just pain in the, you know. I'm filmed, sorry. Okay? What's the history of partitioning? Beginning with SQL Server 7, Microsoft provided us the proportional fill algorithm for file groups. The concept that we have talked earlier in DempDB. So just a round robin allocation. So when you are putting your files on different physical drives, you can spread evenly the I/O operations between multiple different physical drives. That's a functionality introduced back with SQL Server 7.0. We also had partitioned views. We'll talk about them later. They are still needed. They are still needed. A very old but very, very interesting technology. Because partition tables are alone not really good, because partition tables also have some negative side effects. Beginning with SQL Server 2000, Microsoft made partitioned views updatable, of course with a huge amount of limitations. And beginning with SQL Server 2005, Microsoft introduced partitioning. And now with SQL Server 2014, 9 years later, Microsoft is finally able to rebuild an individual partitioned online. Just think about that, 9 years. It took 9 years till we can rebuild a partition online. Very, very long time. And with partition tables, we have again a lot of disadvantages. Hello. Let's talk in the first step about partitioned views. So we are talking about the technology introduced back with SQL Server 7.0. Partitioned view means you have multiple individual tables and you create a view and you make a union all. Simple. Means when you apply a check constraint on those individual tables, for example on a date column, SQL Server is only accessing through a select statement. When you're accessing that partitioned view, SQL Server is only accessing those tables that you have requested. So the query optimizer is smart enough to eliminate all the unnecessary tables when you are accessing the partitioned view through a select statement. The prerequisite, you need on every table a check constraint which restricts the data that you have in that table. For example, in the table of 2014, we have a check constraint which is telling us data goes from the 1st January to the last December of 2014. Means when we are returning all the data for the current day, someday in April today, I have no idea, SQL Server only accesses in our execution plan the table of 2014. And all the other tables are just untouched. We are not reading any data from our storage subsystem into the buffer pool, because SQL Server knows, based on the check constraint, there can't be any data for 2014 in the other tables. Make sense? What are the pros? We don't need an enterprise edition for that. Partitioned views are part of the standard edition. In each table, we have a separate set of statistics. When we are talking about statistics, statistics have a so-called histogram. And the histogram tells SQL Server the data distribution for a specific index, for a specific indexed column. We can have up to 200 steps in such a histogram. Means, when you're dealing with a very huge table, SQL Server describes with 200 steps the data distribution in your table. Means when you have, let's say, 200 millions of records in one table, every step describes an interval of 1 million of rows. This means the larger your tables are getting, the more inaccurate your statistics are. Just think about that. Means the quality of your execution plans are just decreasing because SQL Server can't estimate accurately how many rows are returned. Okay? As we have said, index rebuilds are online on an individual table as long as you are using the Enterprise Edition. And the nice thing here is we are dealing with individual tables, means we can apply a different indexing strategy. For our current table, for the current year, we just have a few non-clustered indexes. But the older the data is, the more aggressively we can add non-clustered indexes. Because it's just read-only data, it doesn't matter. We are only reading from those tables. You are not changing today any data from 2010. Means your indexes aren't changed anymore. Okay? So that's also a very, very nice side effect that you can index every table independently. Your operational data and your historical data. Of course, we also have disadvantages. We have a huge amount of tables. We have to create all the indexes. We need the check constraints so that SQL Server can make the table elimination when we are accessing our indexed views. And of course, you can have gaps and overlapping values when you are not defining that check constraints very, very precisely. Okay? Let's enter partitioned tables. Beginning with SQL Server 2005, we have now the possibility to create partitioned tables. Partitioned table means that we are internally creating multiple independent partitions. Every time when you're creating a default table in SQL Server, create table blah blah blah, that table has at least one partition. So every one of you is using partitioning. Every table in SQL Server has at least one partition. Doesn't matter if you're running Enterprise or Standard or Express Edition. Every table in SQL Server has at least one partition. And in addition, we can add additional partitions in the Enterprise Edition. In the first step, we need to define a so-called partition function. A partition function is just telling SQL Server how we want to divide our large table. For example, based on a date value. When we are creating a partition function, we have to define if that partition function is left or right based. This means with left based, that boundary value always falls into the left partition. If you have a right bound partition function, that boundary value falls into the right partition. Very simple. Okay? And on top of that partition function, we have to define a so-called partition scheme. And the scheme is telling SQL Server in which file group we want to store that specific partition. So as you can see here, we are able to store every year in a different file group. And in the file group, in the logical container, we have physical files, and those files are on individual storage subsystems. SSDs, very fast, RAID 10, almost fast, RAID 5, RAID 6, RAID 6. The older the data gets, the less performant our storage is. Okay? So very simple approach. And on top of that functionality, on top of the partition scheme, we create our partition table. So we make a simple create table statement, and we are telling SQL Server that we want to partition that table on that specific partition scheme. So internally, instead of one partition, which we have by default, SQL Server creates multiple partitions. Means when we're inserting data, the data gets stored in the specific partition. The partition is mapped to a file group into physical files. Okay? Makes sense? So a very simple approach. What are the pros? The advantages? We're just dealing with one table. Very, very simple. There's no possibility for any error because the partition function makes sure that we have one specific boundary value. It's up to SQL Server in which partition one value falls. With a partitioned view, it depends on your cleverness. If you have overlapping values, you can have that value in multiple tables. It's completely transparent. So for example, when you have an existing table, for a third-party application, you can partition that table completely transparently. Means you don't have to change your application in any way. You're just changing the physical layout of your table, but the logical database or the logical table schema is still the same. So it's completely done transparently in the background. Disadvantages? Microsoft wants to have some money from us, means Enterprise Edition, no chance on Standard Edition. Statistics. There are no partitioned level statistics in SQL Server. We have only statistics on the table level. Means when we have a very, very huge partitioned table, we have one statistics object for an index, and within that statistics object, we have our histogram with 200 individual steps. The larger your partition table gets, the less accurate your statistics are. Just think about that. As I've said earlier, partitioned level index rebuilds are offline till SQL Server 2012. Starting with SQL Server 2014, those rebuilds are online operations. Who was yesterday in my pre-con? What I have told you about online operations in SQL Server? It's a fake. They are almost online. Partially online operations. When we are beginning an online index rebuild, and when we are ending an online index rebuild, there can be a blocking scenario because SQL Server requires a schema stability and schema modification lock. So you still have some blocking with an almost online index operation, even in SQL Server 2014. Microsoft just fools us. And we are paying them for that. Okay? And by default, we can only partition over a single column. If we want to have multiple columns, we need computed persisted columns. Okay? So the question is, what do we do? We have a lot of advantages and disadvantages for partitioned views and also for partitioned tables. What can we do?
Mix them.
We combine them. So we are using a technology which was introduced with SQL Server 7.0. I have never ever worked with that version. I'm too young. But I have already lost all my hair with SQL Server and 2 small children. So what we are doing, we are just combining both things together. We are using partitioned views, and every individual table in that partitioned view is a partitioned table. Almost all our disadvantages are just gone. So as you can see here, I'm creating 2 individual partitioned tables, on which granularity depends on your scenario. In that scenario, I have assumed that I'm creating a partitioned table, and for every year, and I'm partitioning for every quarter. So I have in every partitioned table 4 partitions: first quarter, second, third, fourth. And on top of those, I'm just creating a partitioned view. Defining my check constraints means SQL Server can make a table elimination through the partitioned view and a partition elimination when we are accessing that individual table. Okay? Very simple but powerful concept. Let's have a look on that. That's the last slide. So I'm running here on a SQL Server 2014 instance. So we'll prove afterwards to you that partitioned level index rebuilds are now online operations. What I have created already previously is our very large database with no data in it currently. What I have done, I have created my database VLDB with my primary file group. Primary file group contains one data file. In my case, on the C drive. Not really recommended. Okay? Just to make it easy, I have it on the C drive. I have my transaction log file. I've also pre-sized that transaction log with 2 GB, means we are getting 16 virtual log files. As I've said yesterday, creating a transaction log file with 1 MB, forget it. We have a huge amount of virtual log files. We're introducing a very high log file fragmentation. And then I have created a file group for the data of 2007. And I have added a new file into that file group. That file is on the F drive. The F drive is a memory stick today. You will see later why. Not for performance, but for something else. So the data for the year 2007 is on a USB drive, which is very simple to remove, to fake some storage errors. Okay? I've created a file group for 2008. The file is on the C drive. File group 2009. File is on the C drive. And that's it. So as you can see from the properties, we have multiple files. We have the primary file in the primary file group, one file in the file group for 2007, 2008, and 2009, and the data of 2007 is stored on an unreliable memory stick. Okay? So that's our basic setup. So it's already a little bit more intelligent as just plainly creating a new database with the default settings. What I'm doing in the next step, we are creating now for every year a partition table for 2007, 2008, and 2009. So we are just doing the same that I have demonstrated here on the flip chart. For every year, a partition table with 4 partitions for every quarter. So I'm creating the first partition, the partitioned function. Function is always for a specific data type, in my case date time, as range right, means those values are always falling into the right partition. I have 3 boundary values, means I'm getting 4 partitions. Always 1 partition more as we have specified boundary values. I'm creating my partition scheme, and I'm mapping in that case all my partitions, all the 4 partitions in the file group of 2007. Means our data is on our USB stick. I'm creating my table. I'm defining a check constraint, because afterwards that partition table is used in the partitioned view, which is on top of those individual tables. So I'm creating a check constraint, and I'm telling SQL Server the date key is between the 1st January of 2007 and the last day of 2000. No, it's right, 2008, yeah. And we are partitioning that table on our partitioning scheme. So we're just creating a partitioned table. I'm adding a primary key clustered on the date key, online sales key, and I'm also partitioning that primary key, that clustered index on that partitioning scheme. And now I'm inserting data from the Condoso database, from the table fact online sales, which has around 12 million of records. Takes a few seconds. So we are just inserting here a few 100,000 records. So it's not really a very large database. Just showing you the concept. Takes a few seconds. This takes now, of course, a little bit longer because we're on the memory stick. So, what we can do in the meantime, we can create our partition function for the year 2008. So we are creating the partition function for 2008. So we just have different boundary values. On top of that partition function, we are creating our partition scheme. We are mapping every partition in the file group of 2008. We are again creating the partitioned table. So what we are doing here is the following. Again, create table, 2008. We define our check constraint, and we again partition that table on the previous created partition scheme. And finally, I'm adding my primary key clustered, which is also partitioned. Okay? In the meantime, we have finished here and inserted 4 million rows in our memory stick in 2007. Means now we can insert the data for 2008, which should be now a little bit faster. I had that idea with the memory stick between both sessions on a real toilet. I hope it works. So we are inserting the data for 2008, 3.6 million of rows. We can also check the distribution between those partitions by calling our partition function on that partitioned key column. So when we are running that statement, you can see how much data we have in every of those 4 partitions. So between 8 and around 9.5 million of rows in every partition. And finally, we're creating our partition table for 2009. So we are creating our partition function with the boundary values, the partition scheme. We are mapping everything in the file group for 2009. We're creating the table itself with the check constraint, and we partition that table. We add the primary key clustered, also partitioned, and we are inserting data for 2009. Takes again around 20 seconds. So what we have done now, we have 3 individual tables. Every table has 4 partitions, means in sum we have now 12 partitions. And in the next step, we are creating on top of those individual tables a partitioned view. $5 million. And now we can work in the first step very easy with those individual tables. So here we are just accessing data from July 2007. Means we are accessing data from the 3rd quarter. Means SQL Server is doing here so-called partition elimination. When we are running that statement, And when we look on our execution plan, we have a clustered index seek operator. When we are opening the properties window, you can see we have accessed one partition. Partition number 3, the third quarter. Because July is in the third quarter of a year. Okay? That's partition elimination. Means all the other data isn't read from our storage. It's just untouched. Because that data can't contain any record that we are referencing in that query. That's the power of partition elimination. We are just reading those partitions that we are asking for. And all the other data just remains in our storage. It's not read from the storage into the buffer pool of SQL Server. Of course, we can also access multiple partitions. For example, July to October. Means we are accessing the third and fourth partition here. So when we look afterwards again on our execution plan, you can see we have accessed 2 partitions, partition 3 and 4. Make sense? So very powerful. So you can make here performance tuning without changing your queries. Of course, you have to choose very, very wisely the column on which you are partitioning your table, because that should be a column that every query references so that SQL Server can make a partition elimination. Of course, when I'm running a simple select star, I'm just using the estimated plan, we are scanning the whole index, every partition. So in that case, no, we can't see it in the estimated plan, but when we are running the query with the actual plan, you would see that we are accessing every individual partition. So you have to make sure that your queries are restricting on that column on which you have defined your partition function. Otherwise, partition table doesn't help you too much. We can rebuild a partition online with SQL Server 2014. That's new. On SQL Server 2012, you're getting an error message. Unsupported. So we're just rebuilding partition 1, the first quarter of 2009. It's a new enhancement in SQL Server 2014. Okay? So it took 9 years. 9 years for a very, very simple, powerful enhancement. You can even make data compression on a partition level. You can call the stored procedure SB estimate data compression savings, and that stored procedure is telling you how much space you gain when you run or when you compress a specific partition. The crazy thing here is that stored procedure is only part of the Enterprise Edition. So if you're on the Standard Edition and you're thinking about using compression of the Enterprise Edition, you have no idea how much space you are gaining. So we specify the schema name, table name, index ID, partition number, and if we want to have page or row compression. And the stored procedure is telling us how much space we can save here. So as you can see, we have here 63 megabytes of data. So it's a really very large database. And we can compress it down to 16 megabytes. Just think about that. You're gaining space in the storage, and the data is also compressed in the buffer pool. Means you can gain space in main memory. Of course, you're introducing CPU overhead. Every time when you're reading data, SQL Server has to uncompress the data. When you're changing the data, SQL Server has to uncompress, change the data, and afterwards compress the data again. So you're just introducing CPU cycles. But you're gaining a huge amount of memory in your storage and also in the buffer pool in SQL Server. So for example, we can rebuild our clustered index for the year 2007 with page compression. I'm not doing that now because it takes too much time. For example, You can also use page row compression. You can also specify that you want to compress individual partitions. So for example, when you have a partition table over multiple years, you can say the current partition for the year 2014, uncompressed, I want to have maximum performance. My partition for the year 2013, row compression, and all older partitions, page compression. Means the older the data is, the more compressed the data is. Means again, when you're accessing older data, you just need additional CPU cycles for decompressing and compressing the data again when the data is changed. So you can do here really, really nice things. And afterwards, because our historical data isn't changed anymore, we set those file groups to read-only. Means we can't change that data anymore. Normally it should be a little bit faster. Yeah. Other session was in the database. Locking, blocking in SQL Server. So now we are setting up our partition view. We create a simple view and we make a union between all three partition tables. Very simple. And because of the check constraint, the query optimizer knows which data is in which table. So SQL Server knows in the first table we have the data of 2007, second table the data of 2008, and in the last table we have the data of 2009. So, when we are running a select statement against that partitioned view, we are gaining 2 times performance. SQL Server is making a table elimination. SQL Server is only accessing the table for 2007. And within that specific table, SQL Server is only accessing the third partition, because we are querying for data of July. Just think about that. We are referencing all our tables through the partitioned view. SQL Server only accesses the clustered index for 2007, and within that partition table, we are accessing the third partition, the data of July. Very, very powerful. We can also retrieve data from 2007 and 2008. So we are accessing now 2 different tables. Let's run it with the estimated plan. So as you can see, we have a seek in 2007 and a seek in 2008. And both results are just concatenated. So that's the power of partitioned views in SQL Server. We're just using a functionality which was introduced back with SQL Server 7.0. And of course, in every table, we have one set of statistics. So when we look now in that database, you can see in 2008, we have statistics for 2008. We have the histogram with up to 200 steps for 2008. And we have the same for 2009. We have different sets for statistics. Means when we're just dealing with one large table, we have just one statistic with up to 200 steps. Means the larger our table gets, the more inaccurate our statistics are. So we have just eliminated that disadvantage.
Can you insert into such partition view?
Yes, but you have to make it updatable, so you need triggers. Not by default. So you have to do some work on your own to make it happen. But it's possible. So we have seen statistics for every year with up to 200 steps. And what I'm creating now the real fun begins. I'm creating a simple stored procedure which makes in a while loop forever insert activity into 2009. Simple stored procedure. And before we run that workload, we make a backup of that database. Because now I want to show you what happens if we're losing storage. We're just pulling out our memory stick and praying to the demo gods that everything is working. Any questions in the meantime?
What about parallelism and this kind of views that are based on the tables which are partitioned?
Of course, you're just accessing every table individually as you have seen in the execution plan, so it depends which functionality you are using, if you have parallelism or not. So
for example, if you're touching two tables in one select, then SQL Server parallelize both scans of...
because you're just concatenating the data.
Okay.
Okay. So we have done a backup of our whole database. So I have here another drive, a G drive, and we have here in the temp folder, let's check it, VLDB back. So we have here the backup of our database. 770 megabytes. Very large database. So what we do, we take that stored procedure, which inserts permanently in 2009, and we run that stored procedure. Means that is now our production workload we are inserting in our operational table in the data of 2009. So our current year is now 2009, and we have a write activity in that table. Now we simulate some storage error. That's our data from 2007. We don't need it anymore. Okay, it's gone. As you can see, my F drive disappeared. We have lost data. As you can see, our workload still runs. Just think about that when you're doing that only with the primary file group. Your database is offline. We are still running. We are still running. We know now that our file is gone, so we take that file offline. When you take that file offline, the write activity is disconnected. So what you need to do in your application, you just reconnect. You're catching that error and you're just reconnecting. You can handle that transparently in your data access layer. Okay, so you just make a reconnect to SQL Server and everything is fine. So when we go to sys database files, you can see data from 2007 on the F drive is offline. So we have a partial online database. Parts of the database is online. Our 2007 data, as you can see. The other part is online. Just think about that. Impressive? You can't believe it? That is only working in the Enterprise Edition, as I've said earlier. In the Standard Edition, everything is offline. So we have to pay some money for that functionality. Data from 2007, which is lying on the floor. Do you think that that select statement can work? Why? The data is lying here. Come on. The data is in the buffer pool because we have earlier accessed that data. As you can see, not really, too less memory. if you're running that on a machine with more memory, I have just here 2 GB, so not too much. When the data is still in the buffer pool in the main memory of SQL Server, you can still access the data which is gone. Of course, when SQL Server performs a checkpoint process, you have an error message in the error log. No, let's run it. So when we go to the error log, we should have hopefully already an error message. No, not yet. No, not yet, but as soon as SQL Server performs a checkpoint process, you will see an error message. But as long as you have the data in the buffer pool, you can still access that data. Just think about that. The buffer pool is just a caching layer in SQL Server, nothing more. When we access another range of our table, we can query it. Because that data remains in a different file group, which is still online. Okay? And now we want to recover our database. When you are starting with a restore sequence, what you have to do in the first step?
Restore full.
No. Then you have lost data. Data log backup. We have performed the full database backup before I have accidentally removed my memory stick. But in the meantime, we have generated transactions, as you can see here. Means when we are restoring now our full backup, we are losing those transactions. So the most important thing here is you always have to perform a data log backup. We are just backing up the remaining part of the transaction log. Otherwise, you're losing that part. Then we go to master. And now, we are restoring our database. But guess what? We are restoring only that data from the floor. Only the data from 2007. Because 2008 and 2009 is still available. Means we are just restoring a specific file group. When you're only working with the primary file group, you have to restore everything. Now we are just restoring the file group of 2007. We specify our file, our backup file, and now we say, because our memory stick is gone, that we are moving the file somewhere else. And again, our write workload, our operational workload is still running. And we specify the option no recovery, because we also have to restore our data log backup. Otherwise, if you specify nothing, default option is with recovery, means our database is going online, or that file is going online, and you're not able to restore the data log backup. So we make it with no recovery. We store it to the G drive. When we go into the database, we can see in sys database files that we have started the restore sequence. So you can see the file of 2007 is in restoring state. So we're just restoring a part of a database. Just think about that. And the other part is still working. It's still serving our business. And finally, we restore our data log backup, and we specify with recovery or nothing, means that file is also going online. Nice, isn't it? We have lost data, and we were able to recover that data without going offline. The only thing, when you are taking that file offline, is that SQL Server disconnects your workload. So the only thing that you have to perform in your application is to reconnect to SQL Server, nothing more. Everything else is handled transparently in the background. Impressive? Let's stop that. It takes some CPU. So when we run our select statement again, it's working again. It's just historical data that we have retrieved, that we have restored from a previously taken backup. We have lost nothing because it's just read-only data. Okay? What we can also do, dbcc check DBs. So I'm again running some code that I haven't written. The problem with dbcc check DB, when you have no file groups, only a primary file group, you have to check DB your whole database. And the check DB of the whole database takes a huge amount of CPU and storage activity because you have to read your whole database from the storage and you have to check the whole database for consistency. So when we have multiple file groups within our database, we are able to make a dbcc check DB on a file group level. For example, 2007. Just checking the file group of 2007 for consistency errors. Takes, of course, some time. We can also make a dbcc check DB for 2008. Oops. So it's very, very, well, cool. Some error. I have always crazy things when I'm running code from Bolwano. I have to check that later. But you get the concept. You can make a consistency check of a part of your database. Just imagine that. Instead of running a consistency check across the whole database, we are just checking a part, a specific file group. So for example, when you have a database with multiple terabytes, you can say, okay, every weekend I'm checking one specific file group instead of the whole database. So as you can see, with file groups, we are getting a lot of advantages. It's just a logical container, but that logical container helps you everywhere within that database, especially during backup and restore. When we are now running here backup, it doesn't make sense to back up the whole database because the data from 2007 and 2008 isn't changed anymore. In that case, it makes sense only to back up the file group of 2009 because in 2009 we have our read-write activity. Okay? Questions? Impressive?
How about creating indexes when the partition is read-only? We can't create indexes on
when the file group is read. Yeah.
group is read-only. We can't.
You can't create them.
I
Yeah.
have to create on another.
Yeah, but you can make the file group just with white. So it's a simple flag. For example, when you want to create an index. So as you can see here in the properties, it's a simple flag. Nothing more. So you create your indexing strategy for reporting in your older file groups, and afterwards you're just setting that file group read-only. Means nobody else can change any data anymore. And also adding indexes. The misconception here is that SQL Server doesn't acquire logs anymore. That's not true. Even when the file group is read-only, SQL Server acquires shared logs for reading. That's just a misconception that SQL Server doesn't acquire any logs. Okay? So SQL Server is still locking the data, even when nobody else can change that data. Other questions?
How about moving already existing databases on one big file group into separate?
Yeah. Well, in the first step, you have to design how you want to split up your data. Of course, when you are using partitioning, you are not partitioning your whole database. Mainly you are partitioning some specialized tables. Tables which are just very huge. Orders tables, maybe logging auditing tables. Okay, but not the whole database. So maybe when we are looking on a file group level look on that database, maybe you have a common file group where you have all common unpartitioned tables, and then you have some separate file groups for your partitioned tables. But we are not partitioning the whole database, just those tables which are getting very, very large to deal with the various problems that we have seen earlier.
Yes, and how about smooth method moving the data from this huge table, unpartitioned table, into partitioned?
You are just rebuilding your clustered index into the different file group.
And if it contains some blob data, the table, is it will it be possible to
move
index online?
Till 2012. Till 2012, yes. Previously not. Oops, they have changed it in 2012. So in 2012 you can rebuild it online when you have LOB columns, but not before SQL Server 2012. But the easiest way to move data between file groups is just to rebuild your index, your clustered index. Your clustered index is your table data, to rebuild it in a different file group. In that case, SQL Server also moves your data. Other questions? Perfect. So what we have seen, very simple, we have seen that the default settings with just a primary file group doesn't really work when we are dealing with larger databases. As we have seen, we can use partitioned views in combination with partition tables to overcome various limitations of partition tables. For example, that we only have one set of statistics on the table level. And the most important thing is that we should really carefully plan our database with multiple file groups. As you have seen, when we have multiple file groups and we are losing some older data, it doesn't really matter, because in the Enterprise Edition, file groups can be offline and online. The only prerequisite is that the primary file group and the transaction log must be online. When you're losing the primary file group, when you're losing your transaction log, you have lost your database. When you're losing a different file group, it doesn't really matter as long as you have a backup. Okay, so thanks for attending. I hope you have enjoyed that session, and stay tuned. Enjoy the evening party, and let's see us together tomorrow in my session where I'm talking about the dangerous beauty of bookmark lookups. Thanks.